Good afternoon, everyone. We're going to get going here in a few minutes. Just gonna let a few more people jump in, and we'll get going. Okay. Good afternoon, everyone. Welcome to our second installment of our PWCP Summer Speaker Series. Today with Alex Boersch, a producer from Elie, Manitoba, joining us to talk about improving soil health through innovative farming solutions. Um, my name is Dan Cox. I'm the project manager for the Manitoba Association of Watersheds. We are the lead recipient on the Prairie Watershed Climate Program that many of you are familiar with. And I'm really looking forward to having Alex speak today. For those of you that were a part of our joined for the cover cropping topic on the Summer Speaker Series, thank you for joining again today, and we'll have one more coming up later in August. Just a few reminders for today. The presentation is being recorded and will be posted to the Manitoba Association of Watersheds YouTube page. The first session from back in July is already up there and posted for everyone to view. Alex, you have oh no, Alex, put your hand up, perfect. Please use when it comes to questions today, please use the Q&A function in Zoom to put forward your questions, and they will be answered following the presentation, or if Alex sees some as he's presenting that he'd like to answer, he'll answer them then, but ideally we are answering your questions at the end of the presentation. And if we have any unanswered questions, they'll be followed up by Ma following today's event. Today's event is eligible for CEUs under nutrient management. If you are looking to get some credit for CEUs today, you can scan the QR code on your screen right now. That'll take you to the CCA app on your mobile device to receive those immediately. If it doesn't work for you, you can email me following the event and I can manually send in your attendance to get credits for CEUs. So, and I'll put this up at the end of the presentation, end of the session here today as well. Just a reminder of PWCP and the program that is being delivered through Manitoba and Saskatchewan. They do cover 3 eligible BMP streams, including expanding the adoption of rotational grazing, improving nitrogen management, and increasing the adoption of cover cropping. And today we'll be focused on improving nitrogen management and improving the soils and Alex's experiences with that. So with that, I would like to introduce Alex Boersch. Alex grew up on a grain farm in Elie, Manitoba. He has a bachelor and master's in agribusiness and science from INP Perpan, which is a university Toulouse, France. He has worked for 2 years in Toronto for DG Global Inc. as a grain trader and moved back to the farm in July of 2017. The farm was founded in 1988 by his father, Andreas Boersch, who immigrated from Cologne, Germany. They currently farm 3,800 acres of conventional grain production and 1,200 acres of organic, trying to farm as regeneratively as possible on heavy clay soils. So again, look, thank you, Alex, for joining us today. Feel free to turn on your video and share your screen, and we will you can go from. I'll stop sharing, and you can take it away.
Sounds good. Thanks a lot, Dan. Here, I'll just get the sharing underway. Everything good there?
Looks good. Yep.
Okay, perfect. No, thank you very much. So yeah, my name's Alex Boersch. Farm here in Elie, Manitoba, in the Red River Valley, just west of Winnipeg. So I have about a 5,000 acre grain farm with a little bit of animal integration starting to happen as well. So today I'm going to talk to you guys about nitrogen management. And we're going to look at it from kind of a multi-pronged approach, which I'll get into here in a second. But basically, I wanted to start it off with kind of where we're at right now in agriculture. I know beef prices are really good, but from a grain perspective, things are getting really tight. And I think everybody's farm goals is long-term higher profitability than kind of average, and to improve our soils. And our biggest problem is definitely erratic weather, which we've kind of gone through here in the last 5 years, where it's basically you get everything or nothing. So it's heavy isolated rains with long dry periods in between. We've got high equipment costs, high fertilizer and seed costs, high land costs. And as you can see from some of the data here, farm debt has been going through the roof. So what we have to do is be smart with our money and use it efficiently, not only from an environmental perspective, but also just from a profitability perspective, because unfortunately our budgets are not going to balance themselves. So basically, the way we approach our nitrogen management on our farm is through a biological approach, a chemical approach, and a physical approach. The biological approach kind of involves the incorporation of more crop diversity. So intercropping, cover crops, so affecting your carbon to nitrogen ratio and your fungal to bacteria ratios, biology, or what some people would call bugs in a jug. And that I think is more important if you don't have animal integration. Then we have the chemical approach, so chelating and cell sensitization, so using carbon sources to get better use efficiency out of fertilizer, especially nitrogen, melted urea. So if you do have a good crop or you want to do split application, just a more efficient way to apply nitrogen in crop. And then balanced nutrition. So balanced nutrition is actually super important for nitrogen management and using your nitrogen efficiently. And then the last approach, which is actually going to be new to us going forward, is controlled traffic. And so addressing compaction and just basically ensuring that your soil always has enough oxygen. So some of the expected outcomes from this will be reduced commercial fertilizer use by increasing fertilizer use efficiency, increasing water infiltration and soil aggregation, increased stable and active organic matter, the important part being stable, which we created more organic matter over the last while, for example, on our farm by just having a good rotation. But it was still a fairly simplified 4 or 5 year rotation, with probably more tillage than there should have been. And so are we actually gaining stable organic matter and active organic matter that's actually cycling nutrients constantly? Reducing dependence on fungicides and insecticides. So with a healthier plant, getting away from using those as much as possible. Spoon feeding our crops through enhanced nutrient cycling, and then improved margins and yield stability. So intercropping is probably the easiest step into all of this. And it's really easy to see why. It's especially if you're using legumes in your intercrops, you basically need no nitrogen. From all our trials that we've done, anytime we've added nitrogen to an intercrop where there was a legume, all we did was shift the production from one crop to the other, and then our profitability ended up being about the same. But we just delayed maturity as well, and so there kind of was no point in it. And we just want to feed the biology in our soil with more than one type of carbon and sugar. So we think in the long run that if we want to build our soils with more fungi, we need to intercrop more. And I think there was a study that just came out from the Understanding Ag group and General Mills that showed that on their big 5-year study that they did, that as soon as you added more than one species, so even in your first year without having done anything else, you almost doubled the fungal populations just from intercropping. Um, yeah, and then just fighting weather risk. So we've had really unstable weather, and so in certain years, one crop will do better than the other one. So it's kind of insurance, which is good to have because crop insurance is kind of hard to get, or it's hard to get good coverage with intercropping. But this is the most interesting part here. So for us on our own farm, the last few years, probably our best paying crop has been pea barley. And that's been using more specialty peas, but this is just an example with regular yellow peas and barley versus canola and straight barley. And these prices are probably even worse now than when I made this in the spring before seeding. Um, I think that there's a lot to be said about trying to save money from using less inputs by going into intercropping. And this is probably our favorite one, just because it works really well from a maturity perspective, and it also barley is not a crop we typically grow in our rotation, so it's nice to have something else, and you don't need to worry about the pea splits in your barley for marketing purposes because it's just going for feed anyways. Another interesting part we've seen from intercropping is, for example, in Piola, on certain occasions, we've seen when we've had really high flea beetle pressure that we've had almost no flea beetle pressure in the Piola intercrop. So we didn't have to spray insecticide there, even though we had to spray some in the field right across where there was just pure canola. So just and the other interesting thing is we've noticed also in some of the intercrops is you get increased nodulation from the legumes. So I think they're trying to compensate for some of the lack of nitrogen or that sharing. And harvestability from intercrops for certain hard to harvest crops is also improved, especially in the pea side of things. Um, and most of them are fairly easy to separate. So these are just some examples of some of the intercrops that we've been doing. Um, and like in the Piola example, we're seeding basically 3 pounds or 2.5 pounds of canola, and then a normal seeding rate of peas. On the pea barley, because we're trying to go after peas and because they're the more profitable crop, we've been going with basically a full seeding rate of peas and a 3/4 of a bushel of barley just to hold up the peas. We've done higher seeding rates, for example, in this pea oat intercrop where the cereal is a higher seeding rate, but then you end up with about 80% cereal yield and about 15 to 20% pea yield. And in the scenarios where like we've gone to the 3/4 of a bushel of barley, we've ended up with anywhere around like 36 to 40 bushels of peas and another basically 40 to 45 bushels of barley. And so it becomes a lot more 50-50 even split, which is interesting. We've also done lentils flax a couple times. This year it turned into a little bit of a disaster because I thought it was going to be a drought this year, and we ended up getting 16 inches of rain in the first 8 weeks after seeding. So that was probably you can blame the excess moisture on me this year, but it was interesting. So even this year in the areas where it's high, we only put 3 pounds of flax with the lentils, but it helped hold up the lentils, and we still ended up with 20% of the yield. So this was basically a 30 bushel lentil crop where we ended up with 30% of or 20% of the yield being flax in that mix. And we used no fungicides at all, which most people use at least 2 fungicides on lentils in Saskatchewan, and really nice samples. So I think there's a lot of potential to maybe expand some of the production areas for some crops too, from a disease management perspective with intercropping. Soyola is another one that we did. That one hasn't been super popular for us, but I think if we could do alternating rows, this one would be really interesting. Because here where we did it, the profitability was the same as pure canola, but so it wasn't worth the extra separating cost. But I think if we can keep them separate from each other in alternating rows, then um, I think the LER, like the land equivalency ratio, could be improved on this one. Wheat flax, this is from this year. I did this one about 3 or 4 years ago, where I did a full seeding rate of wheat and then just a half seeding rate of flax. But then I ended up with just a few bushels of flax and of basically full yield of wheat. But this year we tried it the other way around, and we went with 1 bushel of wheat and a full bushel seeding rate of flax, and it looks really promising. It looks excellent this year. Um, Considering everything that it went through and being underwater about twice after seeding, really excited to see how this crop works out going forward. So after intercropping, uh, this is something that we're tending more towards even than maybe the intercropping in the long run, because of some separating issues sometimes with marketing if you're going for certain markets, but it's relay crops. So instead of growing as much Liberty Link canola, maybe going more to some Clearfield canola and underseeding it with clover or alfalfa, and taking advantage of your full growing season without ever having to touch your soil again, and still not having to compromise on herbicides. So here we see, this was in a super dry year when I took these pictures. This was 2019, but you can see that the rooting depth was unbelievable on the alfalfa and the clover. And the next year we were really worried because we were going into another dry year the next year in 2020, and we had oats going in there, and we tried spraying it out before the crop actually came up pre-emerge, but the Roundup did absolutely nothing to it. So then we sprayed it out in crop post-emerge when at normal herbicide timing, and that ended up being our best oats by about 10 bushels. So I think that we kind of are too scared sometimes maybe from water losses when there's other factors that will affect crop production as well. And so that, and it didn't really affect the yield at all of the canola. It kind of made harvestability slightly a little bit harder because um, there's a little bit more green material in the swath. But overall, I didn't have any comparisons that year into how much extra residual nitrogen we had in the next year. But from other relay crops like forage beans under corn, there's about, I know Covers and Co did a study where they had about 50 pounds more residual nitrogen the next year for the next crop. So it'll be interesting this year to see, because we did that last year, and we'll see how it affects yield in the following crop this year. And we've been doing relay cropping also under hemp with red clover. Had some amazing stands there as well. And the difference in, like, where on the headlands where we didn't get a catch and inside the field from soil texture perspective are unbelievable. Hairy vetch and corn is another one that works really well, where there's still a lot of compatibility with using Roundup. It sets the vetch back, but in a wet year like this, you almost want to set it back. Otherwise it'll get a little bit tall for harvest. But there's a lot of opportunities out there that we might not think of necessarily that can produce free nitrogen for us for the next year and create soil diversity for root exudates and soil texture. And then you have areas like in between the corn where typically there would be nothing but bare soil. So when you're getting big rains, you could get erosion. All these factors can be mitigated with some of these relay crops. And I think there's a lot of solutions out there where we can seed it right in the spring and still have good weed control and good nutrient cycling. And I'll kind of get into the carbon and nitrogen ratios here thing in a second, but I think we also, especially in years where we have moisture like this year, underestimate what the potential is for cover crops in the fall. So in the top left picture here, you can see, and the bottom here, these were seeded beginning of August, middle of August, and end of August. Um, so it was just basically taking everything that we had left in the bin. So barley, oats, peas, lentils, flax, bit of soybeans, and seeding them all in the fall post harvest and getting some unbelievable growth, really good nodulation without inoculating, and really taking advantage of at least another 50, 60 days of photosynthesis. And we saw that some of the crops actually stayed really green even after the first snowfalls. And then in the following spring, so we're talking about carbon and nitrogen ratio, because bacteria have a 5-to-1 carbon and nitrogen ratio. And so when they're trying to consume carbon, they're tying up nitrogen in your soil. So if you can feed them with a higher nitrogen cover crop in the fall, then you're reducing that N loss that you're going to have, or N tie up. And in this video, you can see where we had Austrian winter peas and after fall rye, and then we also had some fall rye come up as well. That straw the next spring was so brittle and just ready to just explode and fall apart. It was amazing. And on the right, you just have non-GMO corn underseeded with alfalfa, and it was the same kind of idea the next spring. So if you're not going to use any cover crops, I think something that is becoming really interesting is using biology. So whether it's a compost tea, whether it's a more specific strain, but to break down residue. And I think to really promote fungi. So I think the key is saprophytic fungi. And because they're one of the only organisms that can break down lignin, so straw, without nitrogen. And so basically all it's doing is breaking down the straw, creating it more stable aggregates, and then allowing the soil to break down that straw without using as much nitrogen, because it's not dependent solely on bacteria to do it. What's interesting here is, and this is kind of getting ahead of myself in some ways, but we're doing a long-term trial where we're comparing using just grower standard versus adding humic acid versus adding humic acid, so a carbon source with our nutrients, and a stubble digester. And you can really see the rise in micrograms of carbon per gram of soil. So that's how many bacteria and fungi total populations you're seeing increases of. And then you're really seeing differences in fungal to bacterial ratios. Now, I don't think you're going to see very big differences in the first year, but over a 3-4 year period, I think this is a really good strategy for getting better nutrient use efficiency, better cycling, better stable carbon in your soil. And then also disease management. There's a lot of soil-borne diseases like Fusarium, Sclerotinia, where in Europe, there's some studies that are showing that, especially from fall applied residue digesters and spring applied, that you can really decrease some of the populations of some of those diseases. So there's that. So your spring kind of starts in the fall. So whatever you do, whether it's cover cropping, relay crop, or maybe a stubble digester to try and cycle nutrients better, that's like kind of your first step, is preparing yourself in the fall for the next spring. But then there's a lot of critical steps starting at seeding, which is the most important, especially in our short growing season, because there's so many less opportunities where we are to do split application nitrogen. Just especially if you get into a year like this where it rains every 3 days, how do you physically do that? So spring timing is really important. So what we think is has really helped us over the last little while is adding key nutrients. So if you're short on something like boron or manganese or zinc onto your seed, as well as the biology. If you don't already have good biology, the goal would be down the road is to hopefully not need this anymore. But because we don't have really a lot of animal integration on our farm, I think for us this is key. Instead of using fungicide seed treatments, to use as many biological as possible to try and get a really wide array of biology in the soil so that your plant can create relationships with the biology in the soil to make phosphorus available using phosphorus solubilizing bacteria or other things like that. Um, and we've also seen a huge increase in nodulation from doing this. So I think that's an important first step, is getting that crop established well. And then the second thing is buffering or chelating your fertilizer. We use humic acid. There's a lot of different ways of doing this, but basically we all know that phosphorus, only 1/3 is actually available for the plant in the given year. But for other crops, like but for nitrogen, we sometimes think it's higher too, but there's a lot of studies that show that it's only really like 50% use efficiency of nitrogen. And when we're over applying nitrogen, we also create big bacterial flushes in our soil, harming the fungi again. So what we're doing is we're buffering or chelating our nitrogen with a carbon source. So trying to keep that carbon and nitrogen ratio in check and slowly release it. So basically the way it works is that the carbon holds on to either the positive or negative charge and neutralizes it for a certain amount of time. And right now, I think in like 4R is super important, but a lot of the focus has been on nitrification inhibitors to try and keep from losing from volatilization or leaching and things like that. But by doing that, we're also affecting the biology in our soils. So we think that using a carbon source is probably a better way of doing it. And then especially in low CEC soils like sandier soils, hopefully increasing that cation exchange capacity and putting more carbon in that soil and keeping those nutrients from leaching down further. Yeah, so usually what we're doing is adding about 5% humic based on our actual N applications. And by doing that, we've kind of reduced our nitrogen applications by 30%. We kind of slowly did it over time. And we haven't really seen any yield differences from our neighbors and from doing different tests. So if a neighbor was doing anywhere from like 130 to 150 pounds N on a wheat crop, we would be going 90 pounds or anywhere from 80 to 100 depending on the field. And we've still been getting really good protein levels. And so I don't think we have a lack of nitrogen. We might have a lack of some other nutrients, which we'll get into in a second, which will make hopefully our fertilizer more efficient. But this is one way that we're using to manage our nitrogen better. And a kind of a byproduct of this is what we've been seeing is definitely a market improvement in our crops in kind of saline areas, so areas along railroad tracks and things like that, where we've been using the humic acid for 5 years now. We went from having no crop to about a half crop, like a 50% crop. So it's not really profitable yet, those acres, but at least there's some competition there for weeds, and there's still something to cover the soil. So that's kind of interesting. Foliar timing. So I think another thing that is really interesting is foliar nutrition, especially in years where you think there's really high end yield potential, and also to kind of get away from using fungicides as much, especially in drier-ish years where it might not pay. So what we've been doing is kind of assessing crops through sap testing and tissue testing, and then kind of building a program over the years. It's really hard to react with them because our season goes so fast, but we're starting to build kind of a database to know like, oh, these are the tendencies of nutrient deficiencies in dry years and wet years, or these are nutrient deficiencies that we're seeing every year. and kind of targeting them, while also, because we're cutting back our N up front, we're also usually adding melted urea as we go in. And there's kind of key critical times in certain in plants growth and to target yield. So in cereals, it would be before at tillering. So basically, if you can do it around herbicide timing or just after, canola timing, 3 to 5 leaf stage, and then bolting and to early flowering. And corn would be V4, V5 when it's setting its head size, and then V10 just before tasseling. So these are just some tips on how to sap test and when. But basically, I think from my perspective, it's very hard to sometimes react to these depending on how your season is going. But I think they're a really good tool to kind of assess, compared to your soil test, what are you seeing um, for a deficiency, and usually there tends to be trends over time. Um, and the interesting part about sap testing versus tissue testing is you're comparing your youngest mature leaf to your oldest mature leaf. So you can kind of see too, if you have really mobile nutrients like potassium, um, you can see shortages by the fact if they're stealing it out of the bottom leaves and bringing it to the newest leaves. So, and the reason I'm bringing this up is I think that actually having a complete nutrient package is really important for nutrient nitrogen use efficiency, because there's a lot of things from nitrogen, over applying nitrogen, that can also just be the fact that you have a deficiency in a certain nutrient. So if you're getting lodging across a whole field, it usually means that you actually have a potassium deficiency. Whether that's triggered by too much N or not, that's another question, but you can probably address it with potassium. But if you're seeing that you're lodging everywhere except for in your wheel tracks, then you can kind of see that it's actually a manganese deficiency, because basically squeezing the oxygen out of the soil in the wheel tracks oxidizes the manganese and makes it more available to the plant. So there's definitely different ways of figuring out what you actually need to make, because when your crop lodges, it is not using the nitrogen that you applied efficiently and you're losing yield. I think I saw a question, but I'm not sure how to bring it up. Oh, sorry. And then the next thing is melted urea. Why? So instead of using 2800 to top dress, because it tends to burn the leaves and you need a rain to make it happen, to make it go into the crop, we've been using melted urea. Melted urea doesn't need a rain. It can be taken up over the leaf. And it's a much more efficient way to apply your nitrogen, because the crop doesn't need to basically reduce it or convert it from a nitrate all the way back to ammonium and then to amino acids. So basically using 3 times less energy or phosphorus to basically convert, and other nutrients as well, as like molybdenum is important in that, cobalt, but to basically convert that nitrogen into usable proteins or whole proteins, so that your plant's not just overloaded with nitrates with low bricks. So we've been using usually about 10 gallons an acre. So when we're making it, we're usually adding 1 metric ton of urea to 750 gallons of water. And that expands to 1,000 gallons. And at that ratio, you don't need to heat the water, because it is an endothermic reaction. So it actually can freeze the water if you go too high of a concentration. But basically, at that ratio, there's no problems at all. And it's really easy to mix up a batch, but you get exactly 1 pound of actual nitrogen per gallon of solution. And by doing that, we think that if we're less front loading nitrogen, then it's going to help protect your soil. And then on top of that, we can kind of assess if we're having a good year. Then we can apply that nitrogen in crop, and we don't have to worry about burning the crop, or but it still is important to kind of apply it in the evening or early in the morning when you have better nutrient uptake, because the humidity is higher and there's no sun stress. And when we're doing that, we're usually adding a bit of either humic acid or In some cases, we're using kelp if we want, or different cytokinin products if we want the crop to be a little bit shorter, um, instead of using plant growth regulators, because I personally don't believe in them. I think there's always a place for them, but they're starting to find a lot of the plant growth regulator um, uh, chemicals in babies' urine and things like that. So I think it's something that we have to really use carefully. And so we're trying to do it in different, more natural ways. Or we're using fulvic acid, especially if we're using other nutrients with the melted urea, like phosphorus, low pH nutrients to try and increase the uptake. And then finally, this is something we haven't been doing yet on our farm, but it's the next step in nutrient management on our farm, amongst many other things, especially water management, but is addressing compaction. So we have all the technology now with RTK and everything to basically match up all our lines. But you see a lot of fields like this where we harvest one way one year, then the other way. We spray it in one direction, maybe don't match up quite with our seeder, and you end up with a crisscross. And then in a wet year, all these lines show up again. And so our goal is to go to complete controlled traffic or going forward. And there's a lot of studies out there in Australia and in Europe that show huge increases in water infiltration, basically equalizing yields in tough years, whether it's too wet or too dry. But one of the most interesting things from a nutrient management perspective is that there's way lower N2O emissions, so nitrous oxide emissions. So it means you're losing less nitrogen because you don't have anaerobic conditions as often, and you're using a lot less fuel. So yeah, that will be definitely something to look out for. And this is from a study in Alberta from Steve Larocque's farm, where you can see wherever there's compaction, there's less nutrient use efficiency, it makes sense, it's obvious, but it's just good to see on paper. And you just have so much better soil structure. Like that trafficked area is just from a caster wheel from the seeder. So I think it's basically, we have to look at it as a global picture. It can't just be a nitrification inhibitor. It can't just be one or the other. It has to be looked at from a global picture. How can we use our nutrients better? And in the long run, that'll also help us with our soil health goals and carbon sequestration. So, I mean, the other part is animal integration, which you can get to that step as well. I have a customer who used melted urea on his barley after animal integration, and he got away with he had better yield where he used half the nitrogen than on the other side. So it's just really interesting to see how you get that cycling, and maybe you mask it when you over apply nitrogen with animal integration. And yeah, so if you have that component, I think you're already way ahead, and some of these tactics will really help push the farm profitability to the next level. Thank you very much.
Thank you so much, Alex. That's some absolutely fantastic insight into your operation and all the different things that you're trying. If anybody has any questions, please put them in the Q&A. I'm not seeing any right now. But just as a quick question, like the high variance in weather and climate the last few years, has that played a significant role in your operations and some of the things you've tried and not tried, and has it kept you from trying certain things, or has it been how's that played out?
So I would say the dry years have definitely kept us from, in some cases, underseeding cover crops or seeding cover crops in the fall. There's definitely been some limitations there. And then this year, unfortunately, the super wet weather that just never stopped, where we got a rain every 3 days. Again, it kind of pulled back a tiny bit on some intercrops, and we really had some big issues with our lentils and our pea barley this year, just from flooding and things like that. So overall, like, just it makes it a little bit harder to plan. Like some of the more water tolerant intercrops, maybe adding faba beans instead of peas or things like that. If you knew you were in a wetter cycle, you would maybe shift that way or the other way. But right now it's so hard because we've had such major swings going from too dry to too wet. We've had the worst flooding ever in 2022 and one of our wettest years ever this year. And then sandwiched in between two of our driest years we've ever had in 2021 and 2023.
Mhm.
And so it's really hard right now to plan exactly what works best in each scenario. But I guess that's why we have a wide rotation so that some crops can do it better than others. But yeah, it's definitely affected some of the ability to do some of this. But yeah, especially I think the hardest part is the fact that it's so inconsistent. It's not whether it's too wet or too dry, because I think there's certain things that would work better in either scenario. It's just that the wild swings are the hardest part to manage.
Mhm. Yeah, I assume the diversity, like you just mentioned there, the diversity is what's helped you get through a lot of the swings and the in the climate and the weather.
Sure.
Yeah. From a funding perspective, have there been programs aside from PWCP that have helped assist your farm on some of these things that you're trying, some of these regenerative agricultural practices?
Not really.
Yeah.
We did a bit for the rotational grazing with the sheep and cows that we have, but other than that, unfortunately, we haven't had very much luck. Also for the controlled traffic, even like we're going to do a 5-year study for controlled traffic to assess compaction and things like that. And the
Mhm.
only way we could get funding for it was to call it a cover crop trial. So it's kind of interesting right now. It was kind of hard to get funding, but yeah, anyways, that's all we've been able to go through so far. Yeah.
With your analysis on the controlled traffic farming, would that be have educational institutions involved in that, or would it be all kind of internal?
It'll be educational institutions involved. So the
Awesome.
University of Manitoba is involved.
Awesome. That's awesome. Great to hear. So I'm not seeing any other questions in the Q&A or in the chat right now. We'll give it another second if anybody has any questions, but um, going into you said you were going to be starting harvest probably pretty soon, which is and you said your seeding was a pretty wide timeline of trying to get seeding this year, which I think is pretty common across the province. Going forward here into the harvest season, you looking forward to good yields and a good crop this year?
So cereals look good, and our soybeans definitely look good. Canola, I would say half is okay and half is really bad. On the bright side, the canola with the underseeded with the clover, the Clearfield canola is probably our best field this year. On the canola side, our corn has made up a lot of ground the last 3 weeks with the heat. And the vetch is also coming in nicely now, but I'm not sure if it's going to be a bumper crop or not because it had some pretty tough conditions. We were underwater a few times here, so our pea barley, unfortunately, other than 2 fields, probably out of 1,000 acres, there's only maybe a few hundred that are good. The rest, we had a lot of drowned out areas this year. We decided to put it on our lower fields, unfortunately, because we thought it was going to be a drought, and we wanted to put it in the rotation there as well. And then our lentil flax, unfortunately, this year has a lot of losses too from drowning out. There's probably going to be as much flax as there is lentils, unfortunately, but that's just, I don't know. I don't think there's, yeah, many crops that could survive going underwater 3 times. So
Yeah.
it's been just kind of a tough year. It'll be a mixed bag. Half the farm will be good, and then half will be fairly tough this year, but that's just how it goes sometimes.
Okay, we did get a question here in the Q&A. Perfect. From Stephanie. Have you tried any other combinations with Austrian winter peas other than fall rye?
So Austrian winter peas we've done with barley and with oats, and both work really well. The reason we went away from oats is because the oats are it's a lot more bushels to separate, and then some of the buyers are kind of hesitant when there's pea splits in there, but if you can blend it off with some other oats, it works well. And this year, it probably would have worked better for me with oats rather than barley, because the barley was really sensitive to the excess moisture in the spring, so we lost a lot of plant stand in the spring. And I actually ran out on a strip of barley, and I had some oats, so I put oats instead in there. All the oats survived, but the barley didn't make it. So in the really wet year like this, then I think the oats matches up better. But overall, we've had really good luck with the barley and Austrian winter peas. It's probably been our favorite mix, other than this year. Yeah.
Perfect. Okay, well, I'm not seeing any other questions. I'm going to put up my slideshow back up there for a second here. If you could stop sharing.
Yep.
Okay, so I put back up on the screen the code, the QR code for CEUs for today. Obviously, thank you to everybody for attending today. Just a reminder, we do have one more speaker session coming up at the end of August around adaptive intensive summer and winter grazing systems with Connor English, a producer from Bradwardine, Manitoba. So please, if you haven't, please register for that event. We're looking forward to having Connor on and speaking around rotational grazing systems. Again, huge thank you to Alex today for his presentation, some great insights, some great data. And we look forward to putting the recording of this session up on our YouTube, and so people can access it, and we'll let everybody know when it's up there. But I think we'll call it from there, since we're not seeing any other questions or anything in the Q&A. So with that, I will say thank you again for attending, and look forward to seeing you all in the end of August. And have a great day, and have a great summer. And for those of you who are farming, have a great harvest season coming up. But thank you for attending.
Thank you, Dan.
Thanks, Alex.